Welcome to Physical Science in the AM. Hot dog, this is an out of sight class, and we've got index of refraction. We just reviewed what we took up a couple days ago. So now we're going to get a more complicated. Hope you got your sign buttons, and I hope you got your calculator set in degrees. Anyone, have you guys heard of radians yet? Okay, you have because you've done pre-calc 30. Nobody else, right? Or is that 20? Oh, is it in 20 that you guys do radian degrees? Oh, okay. Anyways, if you're in pre-calc 30, you haven't yet. You'll be changing calculator modes to degrees. Did you ever notice most calculators like this have a degree DRG button on this one here? Degrees, radians, and then gradients, which I've never used, but it breaks the circle up into 300 portions. Okay. I've never used it. But we want to make sure you're on DEG, degrees or something like that, usually, when we use this formula. Because we have signs, sign of. And I know in grade 10, it doesn't matter what math you took, whether it's workplace or foundations pre-calc 10, you did sines and cosines, etc. So this formula has an index of refraction for the first material, incident. That's why I use an I. And then we have an incident angle. The second material, the refracted one, and then the refracted angle is what goes into the sine. So we're going to be using those buttons on the front. This is where we're not going to put the full waves in anymore. So we're calculating how much this bent away, this is the refracted angle, etc. Or measured to the normal. Right? Before we were just kind of guessing. I just make sure it looks like it's further out or further in. I didn't say it had to be 20 degrees, 32 degrees here. Now we're going to find out what the actual degrees is. Remember that when a wave changes speed as it travels from one medium to another, the wavelength changes, but the frequency stays constant. That might come up. We've used that before. We've never used this Snell's law, so I'm going to do it together. Light travels from air to water with an angle of incidence. That's what it comes in with, 30 degrees. Find the refracted angle. That's our R. And I'm giving you these values for air and water, the N values. You'll always be given them unless the object is promised. So we know that air is fast, and this is slow. So the prediction is what? Will it bend away or towards normal? It won't go straight through. It won't. So when something, with your imagination a bit, right? We talked about a vehicle skidding on ice, hitting ground. So which way does it go? This won't show up in the video, but this slows down and it should go towards the normal. We should get a smaller angle. That's the way the waves should go here. So it should be smaller than 30, right? Now we're going to calculate what that angle is. So we're going to use the old formula. Bring it down. All right. And let's plug in some stuff. The incident or the first material is air, so I'm going to use the N value for it. Mathematically, it doesn't make a difference, but I'm going to write it. It's 1 times. Psi of I, the incident angle, comes in at 30 degrees. We were told this is 30 degrees. So, sine button, 30 degrees. E. NR. Second material is water, so I'm going to put in our 1.3. Sine of R. That's what we want to find. R, balance, not the sine of R. It's two parts. You got to find the sine of R. We'll figure out how that works. So I'm guessing you guys will find it easier to get decimals instead of sign first. So the first thing I'm going to do, I guess I'll do it on the screen. I'll bring up a calculator. Now I do this in the calculator. I'm probably on gradient, so I'm going to change times degree and try to remember in calculus. Degree mode. Everybody should have a calculator up so that you're doing this along with me. I want to make sure you're getting the right number. I don't need to write down 1 times the sine of 30, but I'm going to because sometimes that'll be 1.25. It'll be 1.00 times. I'm going to use my calculator. I hit sine by 30. Some calculator you have to put 30 degrees in. Then it's you would know if you've done this now. Sine 30 degrees. Now, if you know this from math class, what now? You probably didn't remember that. Did you guys know sines of 30? Cosine of 30 is 0.866 and so on. The sine of 45 degrees, 0.707 and so on. You don't have to have those memorized. Just use a calculator. Fine. I'm going to replace this left-hand side now with this decimal. 0.5. I'm going to put 0.50 because 30 degrees has 2 significant. Okay. I'm going over what the algebra trig is to find this. Now, I got to get the sine of R. You can't just divide out the sine. I remember. Oh my God. I'm going to. So I got to get that alone by dividing by 1. So my calculator, I'm going to go to decimal 5, the answer. By 1. I get 0.3759, blah, blah, blah. I don't need to keep that many decimals that are on this. I'll keep 4. 3 to 5. I just like the way around. 7, 5, 9. How do you know? Now, mathematically, this is going back to your math class. I know what the sine of the angle is, 0.3759. How do I find out what the angle is? What button? Second function sine. It'll be sine negative 1. I'm going to write this down. I'm going to left-right reverse it. I'm going to just say R is equal to the sine minus 1 button on the calculator. 3, 7, 5, 9, n. I'm actually not going to type that out because it's the last answer on my calculator. I could just use answer. Favorite calculators, you know how they work, so you can type it. Second function, sine, should show up as sine negative 1. That means the inverse. It undoes the sine. And I can type in 0.2759. In my case, I'm going to let's say previous answer. It comes up with 22.1 degrees. I'm only keeping 2 digits though, so 22. I'll put a degree symbol there. It's sort of like a unit of time. And it's because in math class, you will by the time, who's taking pre-calc 30? Okay. By the end of the course, you're going to have radians of different systems. You're going to use pi radian. Well, I won't spoil the surprise from Ms. Lanson. Is it Lanson you guys are taking it with? Yeah. Oh, some people are taking pre-calc 30 with Jackson too? So it's a mix. Okay. Yeah. But I know I've taught workplace 10, 20, and stuff like that too. You do this stuff there too. So it's not like it's all brand new. What the heck did I have? Oh, I had all this work here. Ooh, there's my first step. Just double checking though that I got 3, 7, 6. I use that here. Okay. Anyways, and so I hope I got 22 degrees. Yep, I did get 22 degrees. So you guys, you're all cool with that, right? I was just checking my work the last time I did this. Okay. Well, that's the toughest thing to solve. If you have to solve for one of the ends, you just hit and get the decimals for sine. It's a lot easier. This is the one I want. Okay, now, something else, because there's going to be an experimenty kind of thing. And here it is. Our lab activity on that sheet. Index of refraction. We're going to find it. Now, pause the video. Just busy handing out stuff. All this good. So, I'll read through this. Index of refraction. You need a protractor or a ruler? Okay. Since light travels in waves, we can assume it works the same way as it did with water waves, and we've seen this already. Think about how the incident ray will bend, or refract is the best word, towards or away from the normal when it moves to a faster or slower medium. We use the word medium to mean substance, like air, water, glass. And not all glass is the same, too. There's different ways to make glass. We just use, you'll notice most physics books have two different glasses listed. Flint glass and crown glass. I don't know which is which, like your window panes and stuff like this. But there's different glasses, so it has different indexes of refraction. Your purpose, though, this whole thing, is to observe how light refracts when traveling from air into glass. Determine the index of refraction for the glass used in our activity. So we're going to have a way to find the degrees that it bends. Now, I did the math here, and it's only on here so you know it's not witchcraft. We make up the formulas? No, it's through experiment that this was figured out. We solved this. We worked with it once. The incident material is air, and we know that we're going to use a value of 1. We won't go to the extra decimals. Thanks to that. So we put in 1. We're going to be changing the angle all the time, and we're going to measure the angles. We're going to find out, though, the whole goal of this is to find NR. That's the index of refraction, NR, for the glass used in our. The refraction we're measuring is due to glass, so we'll isolate for the NR. NR gives us the value of the refraction of glass. So this is where the formula comes from. Basically, we divide this up. And that's where this, on this side is. Okay? That's where this formula is. There it is. Right. We're going to be using that. We got a chart on the other side. On materials, I'll show you the paper that we're going to use. It's laminated. Again and again. You've seen those ray boxes. I've held them up and keep them low. And we got a glass sensor. I'm going to pause the video because you won't be able to see anything